So, hello and welcome to this webinar. My name is Per Bur. I'm the CEO of Varnish Software, and the topic of today's webinar is you can cache everything, which is basically around caching strategies. The webinar will mostly be talking about Varnish, but I think approximately 1/3 of the content is pretty generic and goes for caching in general as well. So the stuff we say here might also apply to other caching strategies. So this is me. My name is Per Bur. Yeah, and from day to day I run Varnish Software. You have my email address there, so if you have any questions or comments or you want to get in touch with me, please feel free to do so. So a bit of practical information. There will be some Q&A session at the end of the webinar. So you can use the chat or the question frame to ask questions or formulate any comments if you have any of those. Or as I said, you can reach me directly at per.bur@varnishsoftware.com. So we start off by talking about what a reverse proxy is, or a caching reverse proxy. So if this is sort of what your infrastructure looks like, you'll see that it's basically comprised of two things. It's the part that's outside of your direct control and what's within your direct control. And you notice that the outside of your direct control is the browser and any intermediary caches that might be present in your office environment or at your ISP. But what we're talking about is the reverse proxy, which is under your direct control, so you can sort of influence directly how it behaves. So a reverse proxy, it replies on behalf of your web server. It's a sort of a logical extension of your web server. So instead of serving up its own contents, it fetches content from your web server and serves it to the clients. And it caches this content, and it's usually very fast, and it's quite simple. And the last 2 points are tied together because it's basically fast because it is simple. So whereas, for instance, an application server can do a lot of things, really everything, a reverse proxy can only do a very limited set of things, but it does those things very, very, very fast. So I think 9 months ago we got a question from one of our customers if it could cache content for less than 1 second. And that's really quite an interesting question. Does it actually make sense to cache content for less than a second? So in order to answer that, well, obviously the answer is yes, you can do that. But we need to, the bigger question is, why do we actually cache content? So there are 2 reasons to do this. And one would be to sort of improve the user experience. And the other would be to sort of improve the scalability. So, and depending on how much traffic you see, you'll use different caching strategies. So, I mean, there are sites out there that have 100 requests a day, maybe 100 requests an hour, and it doesn't necessarily make that much sense to sort of cache, at least not from a scalability perspective, if you have those kind of traffic levels. Interesting enough, we still actually have customers that actually see something like maybe 100 requests per hour or 100 requests per minute. They still utilize caching, but then it's purely for the sake of the user experience, because a cache can reply to a request much, much faster than an application server can. So instead of waiting 3 seconds for a reply from the application server, you have, if you have really valuable content, really valuable users that might pay you thousands of dollars per month to access this content, it still might make sense to sort of to cache that content. But when we get up to like 100 requests per second or 4 4,000 requests per second, which I think is what Audun, the guy I was mentioned, is seeing, then it definitely makes sense to cache it. So this is, I think, a graph that is taken from one of his Varnish servers. It has a daily peak of approximately 3.5 thousand requests per second, and I think he has 6 Varnish servers, so it totals up to approximately a daily peak of 25,000 requests per second. And this is the CPU usage that he sees on that same server. So you can see that it's hardly using any resources. So this is basically why we want to cache, at least from the sort of scalability perspective, is we want to achieve that, because there's no way you could serve 3,500 requests per second and have a CPU graph that looks something like this. So I'll come back to this this later. Another sort of interesting point of for caching is to use caching because they are easy to scale. Caches are, as I said, they're very, very simple, and they're relatively stateless. I mean, they do have, of course, state in the fact that they have content that is cached, but they don't have any like hard state like a database have. So having a caching layer that you want to sort of scale out is quite simple. Also, we've seen that deploying 2 caches in a data center is a really quick way to get the second data center up and running. For those of you who want to like jump from 1 to 2 data centers, if you very, very simple diagram of what a data center could look like, with an origin server, an application server serving out some content, a couple of Varnish servers, and in order to get this second data center up and running, very easily start out by having only a couple of Varnish servers there. As long as the link between those 2 servers is up, and it doesn't necessarily have to be a fat pipe. It could you actually get quite a few of the advantages of having 2 data centers, and without actually like having the full cost of it. So, for instance, if you want to have like 1 data center in the US and 1 in Europe, this might be a easy way to start that out. Of course, if the first data center burns down, you'll still be in trouble, but sorry, but at least you'll have something. So what do we want to cache? How to develop a caching strategy? There are certain key questions that you might want to ask yourself. Now, one would be, how unique is an asset? If an asset that you serve is completely unique, then it might not make that much sense to cache it. Another question would be, how often is that asset requested? I mean, if it's something that's requested once a year, it obviously wouldn't make sense to cache it. But if it's something that's requested quite often, it might make more sense. Also, how often does it change? If it changes all the time, it might be less feasible to cache that item. And how costly is it to regenerate that item? If it's something that's really, really simple, then again, the upside of caching it is reduced. So we start off by if you want to like do the really, really simple stuff to get started with caching, would be to cache the static content. The good thing, it's very easy to deploy. With static content, I'm talking about images, style sheets, JavaScript, the stuff that doesn't really change that often. However, the performance increase that you'll see will, of course, be limited as modern web servers such as Nginx and also Apache these days, they're quite good at actually serving these static assets. I mean, it's not really that much of a problem to have Apache or Nginx serve 20 or 30,000 requests per second. So it might not be worth doing. I mean, there are still certain things that it can still be a bit faster, as like Varnish doesn't necessarily have to access the file system in order to serve a file from memory, whereas an Apache file server might actually need to do things like talk to the file system, and that might delay it a bit. Yeah. Sorry. The next step up the ladder would be caching content for anonymous users. Now, those would be the front pages and the articles that you're serving, typically from some dynamic system like WordPress or Drupal or Easy Publish or whatever. Caching those items, it's still quite easy, and there's a significant speed up. Typically, we talk about speeding up content delivery with a factor of 1,000. Sorry about that. My throat is acting up. So your server's ability to sort of serve that content will go up with more or less a factor of 1,000. Even if your application has some built-in caching into it. So if you implement a simple page cache in something like PHP, you'll still be it will still be hard for you to sort of get within 1,000th of the capacity of a modern reverse proxy. Now, the moment you start caching content that is not static, you run into the hard question of caching, which is cache invalidation. I can't remember who said it, but some guy said that there are two hard questions in computer science. One is variable naming, and the other one is cache invalidation. And cache invalidation can be really, really tricky. So you need to sort of notify your reverse proxy when your content changes, because it won't know unless you actually tell it. Next thing is that caching generic content. So this is, you have content for users that are actually logged in, but you need, they still, maybe they see a lot of the same content, and you still want to cache that content. So it's still quite easy to set up, because for each URL that you want to cache, that URL uniquely identifies that content. So whenever I see article 534 and you request article 534, those will be identified with the same URL. So it will be quite easy to sort of, you don't have to have special rules in order to find out which version of article 534 to deliver to the various users. The upside of this depends on sort of the number of logged in users. And a question here becomes then, because a thing we typically see quite often, and for instance with systems such as Drupal, which out of the box more or less supports Varnish, is that they are caching content for users unless they are logged in. And the problem is that if the users are logged in, they'll actually have a worse user experience than the users who aren't logged in. And that's kind of problematic because for a website, typically the users that are logged in are the most valuable users because, yeah, they are a bit more loyal. So, and there's also the mixed content, where you have content that is comprised of partly generic content and partly dynamic content that's specifically tailored to the user. We'll talk more about that later. An option which we don't see really that often is caching unique content for logged in users. So this is quite a bit harder to do. And because, so what we're talking about is actually content such as, I don't know, the typical example would be your Facebook newsstream. So where each user's content is specifically tailored to that user. There are a few problems with doing this, and one is obviously that it will require a lot of memory, because say you have 100 different assets and you have 1,000 different users, then you suddenly need to cache 100,000 different pages. So I mean, the memory consumption will, of course, could potentially explode. And cache invalidation can become really, really hard, because you no longer can identify a piece of content with its URL, but you need to identify it based on several factors like the user's unique ID and the URL. And that rules out like the trivial parts of cache invalidation. So for instance, the typical purge calls that you do with Varnish will probably have problems sniping out exactly that version of the content that has changed. But there's still a point of doing this, of course, because if the user revisits the content quite a lot, I have like a web service I use quite a bit, which basically updates its content once a week. But I sort of log into it every day, always. And so for them to actually cache that content server side, for me, actually would still make quite a lot of sense, because it's quite expensive for them to regenerate that content. So there would be a definite upside to it if I revisit that content every day. Yeah, so it's still possible, but it's quite a bit harder to do. Now, we often hear about content that changes all the time, and therefore quite a lot of people seem to be under the impression that it can't be cached. Now, if I sort of if I could be a bit and say that there is no such thing as content that changes all the time. I mean, at least for humans, like detecting 0.5 second of caching is practically impossible unless you do things like scripting to sort of detect that. But it can have a huge impact on your server to just have like a second or half a second of caching. So I can tell you a bit of a true story about customers of ours. Now they have a setup with I think 25 different news sites running on one setup. They were running with 2 or 3 Varnish servers. Each story had the number of comments attached to it on the front page. So the story, the title of the story was there, and there behind that in parentheses there was the number of comments that have been written on that story. And this was actually quite well designed. So the comments, the client would request basically one JSON file, which would then list all the comments and the article IDs, and use JavaScript to sort of place the comments around on that page. Now, that generating that JSON file was quite intensive, and was a really, really heavy database query to sort of to generate that JSON file. And since people were writing comments all the time, they declared that that file can't be cached. The moment we went into production, disaster ensued, as basically the database died. Because for every front page view, the database had to do this massive query, and it basically, yeah, it died. So we added 5 seconds of caching, and the load on the database server went back to 0, which was what it was supposed to be. Now, I don't think anybody were able to sort of detect that there was a 5-second lag from the moment that you enter the comment until the counter on the front page updated. Now, back to sort of mixing generic content with personalized content. The really, really important technology to use here is edge side includes. Now, edge side includes is a sort of markup that you can add to the HTML, where you can have Varnish go through the HTML, and where it finds this specific markup, it will insert other pages. So if you look at my fabulous web design here, a typical article page on some random news site, you can see that there are certain elements of that page that are common for every article on that page. Maybe the menu, maybe on the bottom of the page there will be article lists. There'll be on the right side, there might be a social something on how many of your friends like this on Facebook or whatever, and there might be like some external service that links to the weather, or I don't know what. But these things are common on all, or at least a subset of the articles that are out there. And because these things actually have their own life independent from the articles, and they might be global. So, for instance, if one of these lists changes for a typical Varnish setup, that would mean that you would have to actually invalidate every piece of content, every article view that's in Varnish for that whole site, which is really, really inefficient, because it might be something like a typo in one of the lists, and as you correct that typo, then you have to invalidate everything and regenerate every piece of every cached view of those articles. That's extremely inefficient. So it also, edge side includes will also allow you to have individual cache policies for each element. So for instance, you could see that the menu could have like a 1-year caching policy because it doesn't ever change. or you could have like the lists should be automatically updated every 5 minutes, and the apps maybe 30 minutes, and maybe the social thingy that you have in the lower right corner should always be fetched from the backend, no matter what. Yeah. So this is basically what the edge side include look like. You have your typical HTML, and you can see sort of the ESI colon, which indicates this as an edge side include keyword, where the keyword is include, and it includes the URL to the menu. I think the URL could also be like absolute URL. If you have, if you're fetching ESI elements from several different backends, you might want to use absolute URLs there. Now, enabling ESI in Varnish is quite simple. It happens in VCL fetch, which is executed after the headers are fetched from the backend, which means that you can, for instance, have the backend indicate through a HTTP response header that edge side include processing is to be run on this object. And then basically you set bresp.do_ESI to true, and Varnish will go through that document looking for edge side includes to process. Another way of doing it would be to look at the URL, maybe because you could have everything that is supposed to be ESI processed in /ESI, or maybe you just want to do ESI processing of everything that's of a certain content type, like you want to ESI process everything that is text/HTML. The ESI processing app is reasonably fast, so you shouldn't worry too much about spending CPU time ESI processing. Now, cache invalidation is important. Now, especially important with ESI. I mean, ESI gives you the flexibility to update a huge amount of articles very, very easy and very, very quickly. So, for instance, like an article list or the 5 latest stories from the front page. If you have a list like that, if you want to like take really full effect of that, actually invalidating that cache list, that cached version of that list, the minute it's updated, is something that ESI can enable you to have, and which can be really, really valuable. Now, there are a couple of things about ESI that not everybody likes it. The people I've talked to, they dislike the fact that you're moving parts of the sort of presentation logic away from the application servers to the edge cache or to Varnish, and then suddenly you have this split application that partly lives in your application server and partly lives in Varnish, and that might complicate the sort of the environment, the development environment. So not everybody likes that, but then again, the alternative, which is client-side scripting, using client-side scripting to sort of insert content in the HTML, that actually has exactly the same problem, where you then have your application split between the backend and the client side. So I don't know if that's basically up to you to decide what you like best. You should also note that